Hello students, welcome back to Mary Trockers. So today we'll be working through a set of exam style questions drawn from various ZIMSEC past exam papers just to strengthen our understanding in inequalities. All right, so the first one is from ZIMSEC June 2005, paper 1, which reads, solve the inequality absolute value of x plus 3 is greater than absolute value of 2x minus 4. The second one is from November 2008, paper 1. 4a, on the same axis, sketch the graphs of y equal to absolute value of x minus 1 minus 2 and y equal to negative absolute value of x minus 1. B, solve the equation absolute value of x minus 1 minus 2 equal to negative absolute value of x minus 1. Hence, solve the inequality absolute value of x minus 1 minus 2 is greater than negative absolute value of x minus 1. The third one is from November 2014. Solve the inequality 10 minus 2x over x minus 2 is greater than x plus 1. The fourth one is from ZIMSEC June 2016. Find the set of values of m such that the gradient of the line passing through the points m4 and 1, 3 minus 2m is less than 5. And the last one is from June 2020. Solve the inequality absolute value of 2x plus 2 greater than 1 minus 4x. All right, guys, I think you need to understand that when we have modular signs, be it on both sides or on one side, we only square such inequalities if and only if both sides are non-negative or just positive. Then if we have rational functions, right, remember we only cross multiply if it's strictly positive because it will affect the sign. So I will tell you the technique to consider if you want to use that method of cross multiplication. Then I think that's all. So let's go ahead and get started. So we'll start with the June 2005 problem. All right. So June 2005, that's our first one. June 2005, it was number 3. All right, so on number 3, we want to solve the inequality. So we want to solve the inequality absolute value of x plus 3 is greater than 2x minus 4. So like what I said earlier on, we only square if and only if both sides are non-negative. And here, these are absolute value functions. They are positive, so we can safely square both sides. That's method 1. I will show you another method. So x plus 3 squared is greater than 2x minus 4 squared. So x squared plus 6x plus 9 is greater than 4x squared minus 16x plus 16, right? And so it's 4x squared minus that, that's 3x squared, negative 16 minus that, minus 22x, 16 minus 9 should be 7, if not mistaken. Okay, 16 minus 9, that's 7. So plus 7, it's less than 0, right? Then here we can factor, that's 21, right? So factors of 21, so we have 3x squared minus 3, okay, minus 3x minus what? Factors of 21, okay, sorry. Factors of 21 here, right? So we have 21 and 1, yeah. So negative 21, negative 1, okay. So here it's minus 21x minus x plus 7 is less than 0, right? So 3x bracket x minus 7 minus 1 x minus 7 is less than 0. So 3x minus 1 x minus 7 is less than 0. So our critical values, x is equal to a third or 7. So normally, I know we can use the table, but I prefer a graph. So from our graph, right? We know that when x is 0 here, y is positive 7, so it's going to be up there, right? Then we have a third and 7, so the graph automatically is like that, right? So this shaded part here, it means 1 over 3 is less than x less than 7, and that shaded part here, it means x is less than a third, and here it means x is more than 7, but this is positive, that's negative. So when something is less than 0, this is greater than 0, and that's less than 0. So if we come back to this, it was less than 0, so that's our answer choice. So therefore x is an element of real numbers such that 1 over 3 is less than x is less than 7. So this was our solution. So this is method number 1, right? I want to show you another method which is graphical, so that you also practice on the graphs, right? So with the graphical, you need to you need to be a little bit accurate here, right, in order for it to make sense. All right, so remember we have absolute value of x plus 3 is greater than 2x minus 4. So what we are going to do is to sketch these functions, right? I'll try to use the scale here. Okay, so I'll start with x plus 3. When x is 0, y is 3. So 1, 2, 3. When y is 0, x is negative 3. 1, 2. So it's negative 3, right? So obviously, 1, 2, 3 to pass through this. So this section here is x plus 3. But because it's absolute, so the other one is the negative of that, which is negative x minus 3. It's very important, right? Then another one here, when x is 0, y is negative 4. So we have 1, 2, 3, 4, right? Then when x is 0, when y is 0, x is 2. So it's somewhere here, right? Then what else? That's it. So the graph, I'll try to draw it in red. It's like that. It's like that. Okay, they are going to intersect there. So this part here is 2x minus 4. If it's because it's now negative 4, I have 4. 1, 2, 3. Okay. 1, 2, 3. So I have this part here. Then when x is 0, when y is 0, x is 2. Okay. So it's this part. All right, no worries. It's that part now, which is this part. All right, so this, since it's absolute, this one here is below this, so we just draw it like it's broken here, right? Okay, so now I have this other part here, which is now the negative of negative 2. It's now 2x, because I have 2x minus 4 and negative 2x plus 4. But as you can see, these graphs are only intersecting at 2 points, which is this point here and that point. So we need the critical values. So to get the critical values, here we say x plus 3 equal to 2x minus 4. 4 plus 3, that's 7, 2x minus this. So we have x equal to 7. And another one here, we are saying negative 2x plus 4 equal to 2x minus 4. Equal to x plus 3, equal to x plus 3. So equal to x plus 3. So 4 minus 3, that's 1. X plus this, that's 3x. So x will be equal to a third. So here it's a third, and that's 7. So now we want this modulus, the x plus 3, where it's greater when it's above. So the x plus 3 is the one in black. So it's above it here and there, which is, sorry, I think I've shaded the wrong one. Okay, it's only above at this point, right? At this point only, which is that part, right? So between 1/3 and 7, that's when it's above. After that, remember, as you can see, it's now below that red graph, and this one is now below that red graph. So the only solution here, so therefore, x is an element of real numbers such that 1 over 3 is less than x, right? Less than 7. So that's how we, okay, 1 over 3 less than x, less than 7. That's our solution set, right? So we need to be careful with modulus graphs. Okay, now let's move on to the second problem. Okay, now the second one is November 2008. All right, so for November 2008, we want to sketch on the same axis y equal to absolute value of x minus 1 minus 2 and y equal to negative of x minus 1. Right, so quickly, guys, what we need to do is remember, when you're graphing that, we start with the parent function x and negative x. So minus 1 means I'm moving 1 unit to the right. So when I move 1 unit to the right, it's going to be like that and that. So it's going to be at 1 here. But it's now x minus 1. And here is now x negative of that. It's negative x plus 1, right? Okay. Then minus 2, right? So it means the graph is gonna shift 2 units down. So whatever was happening at so when x is 0, okay, this one, it was like that. When x is 0, y is 1 here. So what is 1 minus 2? That's negative 1. So whatever was happening there will now take place at negative. I have negative 1, right? Then it's shifting, since it's shifting 2 places down from here, it's gonna be at negative 2, all right? So this here is negative 2, and that remains 1, right? Don't worry about the zeros. We only need these vertex, the vertex and the y-intercept. Okay, so this equation now, it's now x minus 1, right? So when x is 0, since it's absolute value, okay, when x is 0, why is that? Okay, because this one passes through negative 1, okay? Then when y is 0, okay, then this one, okay, cool. So another one here, the equation becomes x minus, since it's x minus 1 minus 2 is x minus 3, then negative x plus 1 minus 2 is now negative x minus 1. Okay, so these equations, guys, are very important, right? So that's for the first one. Then for the second one, you just come here, right? And what we need to do, since there is a negative, we reflect across the x-axis. So in reflecting over the x-axis, it will be like that. It's just negative of this, so it becomes x minus 1, and this remains negative 1. That remains 1, and that one, if I take the negative, is going to be negative x plus 1. All right, so those are the two graphs. So allow me to bring this up, okay? So let me quickly sketch the graphs. Okay, I need more space there. Okay, I can start with this one. 2 boxes there, it's 1. Let me just say 3 boxes, it's 1, right? And 1, 2, 3, 4, 5 boxes there, right? So this one, that's where my 1 is. So the graph looks like that and like that. All right, so I have the equation negative x plus 1, and I have x minus 1. So guys, you need to know the equations. They're very important to determine the critical values. All right, then another one here, since 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, that's where the negative 2 is, right? Then what else? Yeah, so it's -2, and this point here, okay, and it passes through the same one there. So the graph looks like this, passes through that and passes through that. But what is important is the x minus 3 and the negative x minus 1. So these are the two graphs, guys. Right, so first part we're done. We now have our graphs. Then on item B, it's saying solve the equation. Absolute value of x minus 1 minus that is equal to that. So first I'll do it algebraically, then we can use the graph. All right, so on item B, it's saying we should solve the equation x minus 1 minus 2 equal to negative of x minus 1. So here, let's just move this up here. So x minus 1 plus x minus 1 equal to 2. So it's now 2 of x minus 1 equal to 2. We divide that, so x minus 1 equal to 1. Right, then when you solve, we square both sides. So x minus 1 squared equal to 1. So x squared minus 2x plus 1 equal to 1. So x squared minus 2x equal to 1, right? X squared minus 2x. So x minus 2 equal to 1. So x equal to 0. It's now 0 here, sorry. Right? So x equal to 0 or x equal to 2. I got those two critical points, or we can use the graph. So it's even clear here because you're saying negative x minus 1 is equal to x minus 1, right? So negative 1 plus 1, that's 0, equal to 2x. So x equal to 0. Then here we can say negative x plus 1 equal to x minus 3. So 1 plus 3, that's 4, equal to 2x, and we still get x as 2. We'll get the same thing. Right. Now that we have our critical point, it's saying hence solve the inequality. Hence means use the above result. So we want to see where the modulus of x minus 1, which is this one here, where it's greater than that. So remember, it's greater when it's above. So it's greater. So from this point here, it is greater, and from that point, it is greater. So it means it's greater when x is less than 0 or when x is greater than 2. So therefore, the solution set here, right? So therefore, remember we are solving modulus of x minus 1 minus 2 is greater than negative of x minus 1. So therefore, x is an element of real numbers such that x is less than 0 or x is more than 2, right? So here we are done for that particular problem, right? So now we are moving on to November 2014, which is a rational function problem. Okay, so this is November 2014. All right, so we want to solve 10 minus 2x over x minus 2 is greater than x plus 1. So here, guys, let me start with the easy method. The simplest method here is to bring all functions to one side. So if we say 10 minus 2x over x minus 2, subtracting x plus 1 should be greater than 0. Now put everything under one denominator, right? So it's now 10 minus 2x minus x minus 2 times x plus 1 greater than 0. Let's simplify. It's 10 minus 2x, then it's x squared plus x minus this minus x minus 2 over x minus 2 greater than 0, which is 10 minus 2x minus x squared plus x plus 2 over x minus 2 is greater than 0, right? So now it's 12 minus x squared over x minus 2 is greater than 0. So here, factors of negative 12x, so we're going to use 3 and 2, right? So it's going to be 12 minus 3x plus 2x minus x squared over x minus 2 is greater than 0. And now we take out 3. Then if we take out 3, factors of that, 12. No, it's not this, but it's supposed to be 4 and 3. Sorry about it. Here it's 4 and 3. So minus 4x plus 3x, right? So we take out 4, then we've got 3 minus x, right? Then here we can take it plus x. We have 3 minus x over x minus 2 greater than 0. So we have 4 plus x, 3 minus x over x minus 2 is greater than 0. So our critical values, x equal to negative 4, 3, or 2. Right, so like what I said, I always prefer the graph. So when I have my graph here, I have my negative 4, I have my 3, and my 2. So what determines the shape of the graph is the value of y when x, or the y-intercept. So when x is 0, 0, we get 12 over when x is 0, that's negative. So it passes through this. So your graph will be like that, will be like that, like that. Okay, so now we are looking for greater means above. So this part and that part is the solution, right? Because here we are saying x is less than negative 4. Here, negative 4 less than x less than 2, 2 less than x less than 3, x greater than 3. But what we want is this part and that part, right? So therefore, x is an element of real numbers such that x is less than negative 4, right? X is less than negative 4. Let me check again, sorry. Let me check again. I think, was it greater? Yeah, the sign is greater here, right? Let me just double check before we conclude. All right, yeah, because it was 10 minus 2x over x minus 2 is greater than that, right? I brought that side, right? Then from there, it was 10 minus 2x, right? Then negative x squared plus that. All right, so now it's x squared plus x minus 2x, which is minus x minus 2, right? Then when I distribute this, it's negative x squared plus x plus 2. Then when I simplify 10 plus 2, that's 12. Negative x minus x squared, factors of negative 12x are negative 4 and 3, right? Yes, so if I take out that, right, the 4, 3 minus x, so x is equal to 3, x is equal to negative 4, or x is equal to 2, right? So when x is 0, 0, 0, 0, this is positive, negative, so it is negative, so it passes through that. Since we want it to be greater, so x is less than 4, or 2 less than x less than 3. All right, I believe that's the solution here. Or, like what I said, another method which you could use, because remember, we just want to talk about inequalities once and for all, right? So another method that we can use here is this one, okay? Just 1 second. So it becomes 4 plus x, it's okay. Then x minus 3. Negative x plus 3. Okay, that's good. Yeah, it's fine. All right, so another method which we can use for this problem is we have 10, or we have 10 minus 2x over x minus 2 is greater than x plus 1. So if you want now, you're going to multiply both sides by this one here squared, this one here. I'm not going to do it. I just want to show you, right? Squared, such that this and that will cancel out. So we have x minus 2, then we have 10 minus 2x is greater than x plus 1 times, x squared plus 4x plus 4. So this is the method which you could use. If you want, you can use this method. I'm not going to continue with it, but I just wanted to show you that if you want to, if you decide to cross multiply, don't cross multiply by a negative, rather make it positive. So you're going to square both sides. All right, so with that being said, I'll move on to ZIMSEC June 2016. So I have June 2016. The question reads, find the set of values of m such that the gradient of the line passing through the points, right, is less than 5. So gradient is less than 5. And we know that gradient is y2 minus y1 over x2 minus x1 is less than 5. So since the points are, we are given m, 4, and 1, and 3 minus 2m. So I'll consider these my 2's. So it's going to be 3 minus 2m, right? Subtracting 4 over 1 minus m. Or even you can start with this one, it's still okay. It's less than 5, right? So I have 3 minus 2m, that's negative. Okay, so 3 minus 4, so this is negative 1 minus 2m over 1 minus m minus 5 is less than 0, right? So we have negative 1 minus 2m minus 5, 1 minus m over 1 minus m is less than 0. So it's now negative 1 minus 2m minus 5 plus 5m over 1 minus m is less than 0. So here it's now 5m minus this, that's 3m minus 5 minus 1 minus 6 over 1 minus m is less than 0. So our critical values, right, m equal to 2 or 1, right, m equal to 2 or 1. So now we have that. So we are going to sketch m, function of m here, right? So I have 1, I have 2. When m is 0, this is positive, negative, so it passes through this. So the graph is like that, right? I moved everything here, right? It's less than 5. But yeah, I did. Okay, just give me a second. Yeah, it was less than 5. I moved there, minus 5, minus 5m plus that, 3m minus 6, 1 minus m. Critical values are that. So when when m is 0, 0, 0, that's a negative. So it passes through this, right? So the graph looks like that and that. Okay. So now you have this part here and that part that is less than 0. So m is in the solution set is m is an element of real numbers such that m is less than 1 or m is greater than 2. And guys, it's something that you can check. Let's see how far true is this. I just want to pick 0 here, right? So if I pick 0 there, it means I have 0, 4, and I have 1 minus 1 and 3. So if we quickly find the gradient, it's 4 minus 3 over 0 minus 1, which is 4 minus 3, that's 1 over negative 1, which is negative 1, which is what? Which is less than 5. It's correct. But if you had chosen this, maybe you have 1.5, right? If you plug in 1.5, are we going to get that? Okay, let me see. So if I have 1.5 and 4, then I have 1, then 1.5 is 3, so it's 0. So if I calculate the gradient, it's 4 minus 1 over 1.5 minus 1, it's 0.5. So I have 3 over 0.5, which is 6, which is more than 5. So it violates. So the region there is what is correct. So it's something that you could also do in the exam. Okay, so now guys, let's move on to the last one. We need to be careful on this one. We want to solve modulus of 2x plus 2 is greater than 1 minus 4x. Remember what I said, when you square both sides, these both expressions should be non-negative, right? They must be positive, but we don't know about 1 minus 4x since we don't know the numeric value of 0. So we have to deal with that with caution. All right, so maybe the first thing to do here is to use graphical method first. So let me go graphical, then we can, I'll tell you how to do it algebraically. All right, so here and there. All right, so we start with that one, yx. When x is 0, y is 1. So I just say that's my 1. When y is 0, x is 1/4. So I just say this is 1 over 4. So that's the graph here, right? So this is the graph 1 minus 4x. Then we want to graph this. When x is 0, y is 2. 3, 1, 2. Okay, so y is 2. When y is 0, right, y equal to 2x plus 2. When y is 0, x is negative 1, somewhere there, right? So the graph passes through that. Then, right, so this one is like that. So they are only intersecting at this point. So they are intersecting where 2x plus 2 is equal to 1 minus 4x, right? So 6x equal to negative 1. So x is equal to minus 1 over 6. So they are only intersecting at this point. But now coming back to the inequality, we want this region where the absolute value is more than. So the absolute value is this one. It's only greater at this part. That's where y values are higher than these ones. So the solution set here is just x is an element of real numbers. X is an element of real numbers such that x is greater than negative 1 over 6. Right. Now, let's go algebraically. All right. So in algebraic terms now, we are given this absolute value of 2x plus 2 is greater than 1 minus 4x. Okay. So now the second method that we're going to use, it has two cases that we need to consider. But remember, absolute value of 2x plus 2 simply means 2x plus 2 when x is greater than 0 and negative of that when x is less than 0. Okay, so first case 1 is when the absolute value here, right, is greater than what? Is greater than 0. So it means we have 2x plus 2 greater than 0. 2x greater or equal to 0 actually. So 2x is greater or equal to negative 2. So x will be greater or equal to negative 1. That is the condition here, right? So if we solve now, we get 2x plus 2 greater than 1 minus 4x. So this is 6x greater than 1 minus this negative 1. So x is greater than negative 1. So when you combine, right, negative 1 over 6. So when we combine, obviously what makes sense is greater than negative 1 over 6, because greater than negative 1 and greater than negative 1 over 6, this one makes more sense, right? So therefore, x is greater than negative 1 over 6 here. That's another solution. But let's consider the other case here. Okay, so case number 2 is when the absolute value of 2x plus 2 is less than 0. So 2x plus 2 is less than 0. 2x is less than negative 2. So x will be less than negative 1. This is the condition. So now let's solve the inequality. So when we solve when we solve that inequality, it's 2x plus 2. So it's now negative of 2x plus 2, where it's greater than 1 minus 4x, greater than 1 minus 4x, right? So here, negative 2x minus 2 is greater than 1 minus 4x, right? So 2x here is greater than 1 plus 2, that's 3. So x is greater than 3 over 2. So if we combine this, it doesn't make any sense. We don't have a solution, because here the condition is that x must be less than negative 1, and here the solution is x greater than 2, so we don't have a solution. For this case, there is no what? There is no solution. So the only answer for this is that one. So therefore, x is greater than negative 1 over, okay, let me do it this way. So therefore, the solution set is that x is an element of real numbers such that x is greater than negative 1 over 6. So this is the only solution here. So guys, always, especially for this one, we need to be careful. I think the safest method here to consider is graphical. Unlike this one, you have to be careful when you are making a decision. Last but not least, I just want to talk about this in general. So suppose x is less than x minus a less than b, or x minus a greater than b, and in this case b is just a non-zero value, or b is just positive, right? So instead of squaring or graphing, just know that the results for this one, the standard results are negative b less than x minus a less than b. So it will be negative b plus a less than x less than a plus b. That will be the solution. When it's greater, it's going to be x minus a is greater than b. So x will be greater than a plus b, or x minus a is less than negative of that. So x will be less than a minus b. Right, so let me just give you an example. So suppose you want to solve absolute value of x minus 2 is less than 3, right? First method, you're going to square, since they are both positive. X minus 2 squared less than 3 squared. So x squared minus 4x plus 4 is less than 9, right? So x squared minus 4x, 4 minus 9 minus 5. Factors of negative 5, it's 5 and negative 1. So it's now x minus 5, negative 5 and positive 1, right? It's less than 0. So the critical values are x equal to negative 1 or 5. So when we sketch this, I have negative 1, I have 5. When x is 0, it's negative. So the graph looks like that. But you want it to be negative, so it's somewhere here, which is negative 1 less than x less than 5. But if it was greater, we would consider this part, which is x is less than negative 1 or x is greater than 5. But guys, instead of doing it this way, this is exactly what I was saying, that if you are given modulus of x minus 2 is less than 3, right? Was it less than 3? Yes. So you could just say negative 3 less than x minus 2 less than 3. So negative 3 plus 2 less than x less than 3 plus 2. So negative 1 less x less 5. And you will still get that one. But for greater, I said it's x minus 2 greater than 3. So x minus 2 is greater than 3. So x is greater than 5. And it's even clear here that x was greater than 5. Or you could say x minus 2 less than minus 3. So x is less than minus 3 plus 2. And x is less than minus 1, which is that part here. So instead of squaring or graphing or what, just go ahead and use those results. And guys, that's how we solve inequalities step by step. So we just need to do more practice on inequalities. I will see you in the next video. Take care.